Hello.
Hello.
Adam, is that you?
It is.
Well, I'm here. I promised you I would be.
You kept your promise.
I tried to keep my promises.
Very good.
There's the old
Commendable.
pattern. You should always keep all your promises. And secondly, you should never make any.
Yeah, or at least be very careful about what you promise.
Yep.
Oh, I generally try to be. I'm usually sure I can deliver them.
Yeah. It's a Jewish custom to, whenever one says one will do something, always append the phrase without a promise.
Oh, interesting. So in other words, it's an intent, but not one that you can guarantee.
Yeah. But
Okay.
even when people don't say they promise something, when they just say, yeah, I'll be there tomorrow, or something like that. Then I'll be there tomorrow without promises. But I'll bring it tomorrow without promises.
Hmm.
So,
Well, I suppose that's more or less a reality-based situation because while we would always like to say that we could guarantee we could do what we say we will, we don't control everything.
yeah, we say man thinks and God laughs.
I have a sticker on the wall that says, "Have a nice day," unless, of course, you've made other plans.
Yeah.
Oh. Well, sometimes those other plans are quite interesting.
American rules and regulations often include a clause about acts of God, right?
Yeah.
Which means in practice, you can't actually get reimbursed for anything at all. Right?
Well, yeah. That's one of the paradoxes of, say, something like life insurance.
Yeah.
If the life insurance company doesn't actually deliver, you won't be around to complain about it.
No, that's a good point.
Well, that depends on the type of policy you have. Nobody realizes it. If you have a whole life policy and you reach age 100, it becomes a term policy. All whole life policies are converted automatically to term at age 100, at least in New York State.
Right.
Oh, really? So you're not allowed to, the insurance company really doesn't want you to live beyond 100.
They don't have any tables for it. I worked with a whole bunch of actuaries and I said, what happens when you get to 100? He said, we don't know.
Oh, I see.
The population might be
It's
too
just
little to make statistics on.
Simplified the calendar. Every month has 30 days. And the extra days just don't count.
Yeah, that's how it usually is with interest in banks. They don't care about the year not being exact. So anyway, it's
It
7
would be
o'clock.
nice if we,
Sorry.
Ron, it's good to meet you for the first time.
Well, it is good to see everybody here. Because I'd always thought I was really old at this, but I gather there have been people who are at it longer than I have been.
Yeah. Yeah, I mean, I'm hosting this, but I don't know how qualified I am to speak about the APL's history, being that there are people who have been dealing with APL for twice as long as I've lived or so. But I'll try to run this series, and for now every 4 weeks. And as you probably got a notification, we're recording this. I wish everybody the best of health and a long life. But the reality is that APL has been around for a long time, and some of the pioneers are slowly disappearing. And I'd like to preserve some of their memories, some of their stories, and so on. I'd even say I'm doing it in somewhat in memory of my father. He was one of the early APL adopters. And I never got a chance to record all his stories and memories. I know some things, anecdotes. Yes, and we lost Larry Breed recently. Should have gotten him into an episode here before that, but it is what it is. And as I look through papers, I realize that there are quite a lot of characters in the APL world, both literally on the paper and very much alive. And yeah, I'd like to preserve it for the future. It's interesting thing. So I'll try to invite one very important person for every episode. That doesn't mean people can't just speak up about their history. And so great honor to have Ron here. When he joined Dialogue fairly recently, and I didn't know who he was. I heard that he had been dealing with APL earlier. And then slowly I'm discovering that it's pretty much everywhere I look that somebody made some APL implementation. His name is there on the list of people who were helping to implement it. So
Well, in the early days, when there were only a small number of people actually worrying about APL implementations, everybody got to know everybody else.
My first exposure to a large group of people was at APL 63.
APL 63.
Yeah, goes back a long time. I believe it was in Ottawa.
63? I thought that the first version that was done came out in 66. So was this Iverson's notation?
Well, I was exposed to the notation in Herb Hellman's book.
Okay.
And from that, I went to a company that was using STSC.
Okay.
And company wanted, the IBM SCs wanted to bring it in-house. So since I knew what APL was, I didn't know anything about it as an implementation. They said, he's the point man. I was a systems programmer at the time, supporting OS 360. And that was my first exposure to a working model of APL as a machine notation. From there, I went to a couple of other companies and finally wound up in a large insurance company running CPCMS and virtual machines, and they had the same problem. The actuaries were using STSC, it was costing money, and besides which, the people in corporate data processing were trying to bring everybody into corporate. So I was sat in front of a terminal. The IBM SCs got me access to the internal course that IBM had at the time. Next thing I knew, I was sitting in front of a 2741, trying to follow the course and trying to try my hand at APL with a copy of Gilman and Rose in my hand. That was my exposure, my start. I may be wrong about the year. I just remember that Ken was the keynote speaker.
Okay.
No, but you said 63, and that, I mean, it makes sense. Hellerman's system was released in 64, but clearly it was at least in the works before then.
Well, yeah, I may have it wrong. Adam, you can look it up.
No, it's 63 sounds completely reasonable. As Kurtis wrote in Iverson's book was published in 62. Hellerman's system, which was I think the first somewhat Iverson-y thing that could run, came out in 64. So you might very well have been aware of it in 63.
Look, my memory isn't the greatest. I mean, at 85, I'm allowed to have some memory lapses. But
Yep.
I remember that Ken was the keynote speaker, and he proposed some extension language. What is he talking about? I couldn't remember a word.
So
Well, I first got involved with APL when I encountered it in 1969, because at that point, I had finished the University of Virginia, and the first job I had outside of that was teaching in a high school or intermediate school in Yorktown, Virginia. And I connected with the local college, the College of William and Mary, which had an APL implementation running. And I ended up digging into it and trying a few things there. And in 1970, I got connected with a friend whose father was assistant superintendent of education in Hampton, Virginia, who wanted to expand their computer science course. Because that had started with one person, I think her name was Margaret Steiner, who had worked at NASA Langley and was getting tired of sitting home alone as a housewife. So she decided to start teaching physics in the Hampton City schools. And as a side project, started teaching programming. And they had an IBM 1130, which she did a lot with the kids. And so I came in to expand the program to the other high schools in Hampton. And so I ended up teaching in 3 different high schools during the day, and had an amazing set of students, because this was not a required course. And in fact, the problem the schools had with the course was the kids did not want to leave at the end of the day. They had to shoo them out of the computer room. And this is the time where all we had when each school was one 2741 terminal with a leased telephone line up to the college. And we started a program that way. And along that time, in 1970, before I started the program, I took a trip to visit some friends in Toronto and also stopped by the Burroughs Center in Philadelphia and connected up with Jim Ryan, who was interested in doing APL for the Burroughs systems at that point. So we kept sort of in touch as I was teaching these courses to the high school students. And after I'd done that for a while, I spent some time working at a place called The Computer Company in Richmond, Virginia, which was an APL vendor, as well as a DOS shop. And then from there, I went to APL 72 in Atlanta, which was one of the very first, not the first, but one of the first APL user meetings. This is the meeting in which we designed the ASCII version of the APL terminals and got that laid out in a way that was standardized. It was one of those first times where I ended up meeting a bunch of people, including Larry Breed and some other people from STSC. And then after that, I ended up joining STSC in 1973 and did a number of projects for them, one of which was a personnel database system for the United States Marine Corps. And the other project I did at STSC was the second version of their email system, which got used for many years after that. And then I went from STSC in 1974 to Burroughs to become part of the Burroughs APL implementation team. And I was there at Burroughs until 1977 and did a number of things along the way. And I was deeply involved in the work with the Burroughs installation we had at Volvo, and did a lot of work there measuring the performance of the system and improving it along the way. one side note is when I was taking one of the airplane flights over to Sweden, I ended up writing a full text index for APL so that you could have on a piece of paper a location that tells you where every variable was used and how it was used in your entire workspace. So, and from there I went to data resources in Lexington, Massachusetts, because they were using APL as part of their econometrics time-sharing system. And did some work there for them for about 3 years, and then from 77 until 82. And then in 1982, I went to work with some friends on an APL machine. This was for Analogic Corporation. And the basic idea is they'd gotten in the business of doing array processors for processing CAT scans and constructing images of slices of the brain from a bunch of X-ray pictures that were taken. And we had actually a pretty good machine there. It turned out it was very popular with the NSA. They seem to have bought just about every machine we could make. But on the other hand, about that time in 1982, the IBM Pc came out. And things have been going on in the microprocessor world for a while, since about 1975. And it got to the point where people discovered they could do what they needed to do on a microcomputer, and it would just take longer. So if you had a microcomputer, you could buy it for, say, $2,000 to $4,000. And if you had a big problem, you set it in a closet and let it run for a week, and it gave you the answers. Whereas we were at the point of saying, you can buy one of our APL machines for about the price for a year's worth of time sharing service and have the power of a mainframe at your disposal. And which was actually true. It just turned out that we got undercut by the PC, which was even cheaper than what we were doing. And while it wasn't nearly as fast, you could let it go for hours and hours and weeks to get your results done. And as I understand it, the micro was what basically did in STSC and all the time sharing vendors, because it got to the point where it undercut all the revenue that they had. So a lot of things changed. What we did, while it was technically a success, wasn't a marketing success. We didn't sell nearly as many as we wanted to, although NSA was happy to buy every machine we made. And from there, I went looking with some friends as to what to do next. I ended up then taking sort of a break from APL and went to this small company in the Seattle area called Microsoft. And that turned out to be a good sort of change. I was there initially for 21 years doing Windows and a variety of other things. And then I left to do a startup with some friends to do what I called internet television. The basic idea was, this was in the early days of the internet in 2007. And we noticed that there were a lot of exponential trends on the internet, one of which was the amount of videos available. And even if you figure that, say, only 0.1% were of interest to people outside of their immediate family, that's still a lot of videos that are worth watching. So we went to work with a group of 4 of us, and we built a web scale crawler which could find all the videos available on the internet and find them as quickly as they appeared. And then we took care of the second problem, which is, which of these videos are actually worth watching? And we used some interesting statistical and machine learning analysis to figure that out. And the final thing was, what are these videos about? And we didn't have much processing power. We only had 1 rack and a server in our office. So we couldn't, say, download all the video content and run it through a text-to-speech algorithm. So what we did was to make use of the metadata that went with all these videos. And metadata is kind of a noisy environment. It will have good information mixed with complete lies. So our first problem was to figure out, okay, how do we winnow this down to actual information you can trust? And the key thing was we discovered that not only did we have the URLs for all these videos, we had the sources of all the links that went to these videos. So using some statistical analysis, we were able to come up with a model for each source of links to give us an estimate of how likely it was that a particular source of links pointed to good things. And secondarily, we had a measure of how reliable was each source. Because you have some people who everything they pointed to was absolute gold and worth watching. And other people who 80% of the time they pointed to good stuff and 20% of the time they sent you spam. So using a network of source links, we were able to come up and figure out which were the actual good links. As a side benefit, one of the people on the team had done a lot of work on detecting spam emails. So we came up with a means for detecting spam links. Because there are companies whose whole business is to make it look like something is popular when it's not really. And we were able to detect what we called link farms. And our attitude was anything that comes from a link farm, we assume is poison. It's a black mark against you if you've been linked to by a link farm. And it was sort of funny the way this worked. We noticed there was a particular music video by Britney Spears that was on one of these link farms. And it appears her record label was deathly afraid it wouldn't be popular enough. So they hired these guys to try to make it look popular. So there were a lot of funny things we did. We were technically successful in the sense that we had a website which would play videos on iOS devices. And we had 8,000 channels organized by subject matter with continuous videos feeding into them. But it wasn't successful on a marketing point of view. Our main problem was when I had a version that I submitted to Apple, they wanted to know how we had the legal rights to play all these videos. And we couldn't get past that. So we ended up essentially shutting things down in 2012. And I did several other pieces of work with friends in the Seattle area. And then on a flyer, I got an interview with Amazon and ended up working there for 2 years. And then took some time off doing other things and took care of things like my parents' estates. And then spent a couple of years working back at Microsoft on their archival storage systems. And then left that after a while and got back more or less in the APL environment. I'd sort of been keeping track of what had been going on for years and years and had been meeting up with some friends at Meadowbrook and upstate New York every 2 years on a meeting to discuss what had people been doing in the APL world. So I'd been in touch with what people had been doing, and I knew about Dialogue and what they had been doing. And we got to talking with Morton in about 2020, and wanted to know if there was some work I could do for them on a consulting basis. And we worked out an arrangement, and I started working for them in about May of 2020 and have been with them ever since. So it was a case where essentially I'd been away from APL for about 30 years formally, and then came back into it and discovered that it hasn't changed a whole lot from when I was in there in the first place. The main difference was nested arrays, which had started just before I left the APL world, but had not developed a whole lot, and a whole bunch of extra operators and other implementation details. So, but it was like starting over again, as if I had never left. So that's how I ended up getting back to dialogue.
So were you at Microsoft at the time when Bill Gates considered doing APL?
Well, I got there just after he had been very interested in doing it. And I found that there actually was plans for a Microsoft APL system. And I found some of the manuals for it. It just never shipped.
It went that far that there were manuals for it?
There were manuals for it.
Oh, wow. I thought it was just something they considered implementing, but it was actually implemented as well.
Well, I never got to find out how much actually got written, but there were manuals. And one friend who had been working with Bill for many years mentioned that Bill was really quite interested in APL. And at one point, he wanted to do very elaborate things that were sort of pushing the boundaries on what was considered APL. This was about the time also that the APL Standards Committee got involved and started working through the issues of how to make it an ISO and an ASCII standard. So
I would love to see those manuals. So I have a question. Maybe you know the answer. I always enjoyed the fact that in Excel there were array operations. I always felt that I was the only person in the world who used them. Where did those come from? Was that a link to some APL heritage, or who introduced those into Excel?
Well, the correct answer is I don't know for sure. However, my opinion is that a lot of people knew about APL and arrays at the time, and it sort of permeated the culture. If you look at the things that happen in things like programming languages like Java and other languages, there are all sort of array-like things that showed up. They tended to be variations of what APL did, because APL was, in a way, kind of peculiar in the sense that it had all these strange symbols that you use for array operations, whereas everybody else seemed to be leaning toward giving things English names. And I remember there are various arguments about whether it made sense to use symbols like APL did or to use words. And one of the most cogent argument was, if you play an instrument, say a piano, would you rather play with your staff notation and so on done in English words as opposed to notes on the page? And the obvious answer is English would not work for that.
It's not the only thing. Imagine
there's
doing
sort of patterns you see visually.
Yeah, imagine doing algebra in words like people used to.
Oh, actually, they used to do that.
Yeah, but I mean, just trying to do math through Roman numerals is bad enough. But imagine using words for everything.
Oh, yeah. I mean, first of all, you have to worry about how do you get the whole notion of floating point in Roman numerals?
Clearly base 60.
Probably. Or at least the Babylonians did it that way.
What I understood from my father was that the early spreadsheet managers, or what became spreadsheet managers, and the implementers were very aware of APL, and something like that was the goal, but they simply did not have enough space in the computer to implement all of the power of APL, and so they implemented a bare minimum subset, just product and sum and those kind of things,
Yep.
with the intention that when the computers would develop, they would add more until it had the full power of APL, and then they just never got around to it. It got caught. People cloned it, and then we get this half.
Yeah, there are a lot of things like that. When the Burroughs APL was started, it was sold to Burroughs as the first implementation of a language based on a framework, which would ultimately also implement algol and PL1 and a variety of other things. Basically, it wasn't sold as an APL system. It was sold as the first instance of an interpreter, a very intelligent interpreter. And just, we ended up implementing APL, and there wasn't a need to do much more than that. So there are a lot of smart people who were involved in doing APL. One of the things that was sort of missing was the interactivity, although APL was notable in that it was the very first things which allowed you to type an expression and get your result immediately, instead of punching in on a bunch of cards or paper tape, giving it to another operator and waiting an hour or two for them to come back to you. Just having a terminal there where you could type something and immediately see the result was groundbreaking in those early days. It just wasn't something you did. The place where we sort of missed is at about the same time, at about the 70s and 80s, there were people at Xerox PARC who were doing graphical user interfaces. And this was sort of something that APL missed out on. It was usable and interactive so long as you had something like a character terminal. And we went a long ways with that, but it took a long while before it was truly tied into a graphical user interface. And I think Dialog was one of the first groups that actually did that and did it well. So there are a lot of currents of what goes through in the APL community over time. Things that people realize are possible, that things were there all around and just nobody put them together. There are a bunch of things like that. Jim Ryan, who I'd worked with quite a lot, mentioned that one of the most amazing things he saw was the 1968 presentation of the use of a mouse and a bitmap screen. And people went away from that and says, wow, this is what everything should be. That was Doug Engelbart's presentation. And it certainly started lots of things.
The mother of all demos or something like that.
That's right. It really was.
Full joint computer conference.
But we're
It was
still
one
not
of those
there.
things which the people who saw at the time and understood the significance of it really was groundbreaking.
We're still not there. We've gotten a long way towards that type of usability, but not quite. I watched it not a long time ago. And so some of the things you could do with that system, you still can't do.
Well, what do you have in mind?
It was, I think it's some of the direct connections between things that you can drill into everything. Everything is like one giant tree view, and you can drill in and go out of everything. And there isn't an artificial barrier where you have directories with directories and then files, and the files are very distinct. You need applications that are appropriate for those files. It's not integrated. Right? Microsoft has gone a long way with having preview in the Explorer and so on, but it isn't as smooth as they had it in that demo.
Well, if you think about it, the thing that comes mostly out of that is the internet itself and the World Wide Web, because that was really what came out of the World Wide Web. It made the internet very convenient, because the internet existed by 1969 in terms of connecting computer networks together across the country and the world. But it took a while to make it accessible to everybody. It's a bit like the use of email. When I wrote that second version of the STSC mail system in 1973, 74, very few people actually used email. STSC and IPSA were unique in that we had a network that was not only national, but international. So you could actually have communications with people around the world, but they had to be on that network. And our email used a central server to keep track of the emails, So it wasn't completely as distributed as the current internet, but it was along that lines. So
was an
email is
intranet,
what held the
right?
company together. Because we had people working on the west coast of the U.S. and east coast and in Canada, and there were some people connected in Europe as well.
But it
wasn't walled garden. I mean, it was email among users of a particular system. So there are, you know, many instances of that grew up. America Online being certainly a famous one among others. And I think the real breakthrough for email was when there were gateways that enabled anyone to talk to anyone universally, regardless of which particular garden they were hosted on. And I think that's what made it take off.
And
that's
what
and the
made
fact that it was
intranet.
open source. One of the things that happened about the time that World Wide Web started is there was another protocol that had gained a lot of following from one of the universities. I think it was the University of Minnesota. And I think it was called the Gopher Protocol. And it was spreading like wildfire. And then the university decided it might want to charge a small fee for large systems that used it. And then its usage just vanished. The key was to make it so that there wasn't some gateway which put a toll on everything going through it. And that made all the difference in the world.
It was a delight. The barrier to entry to Gopher was so low. It's really a shame that never really took off.
And as I say, it really was taking off. It was just to the point where the university, where it started, decided to extract some money from it. And that was deadly. When I was at Microsoft when they made the decision to suddenly back the internet wholeheartedly. And there were a lot of heated discussions there. One good friend who actually was in charge of the development for Internet Explorer had a lot of arguments with Bill about it. And at one point, Bill called him a communist. He was arguing that we should just sort of set this Windows thing aside because the really big thing is going to be the internet. And Bill wasn't having it. Although he did agree that we had to be involved in the internet. There was one big memo that Bill sent out saying, okay, we've just about controlled about everything we can here, but we have to be on the internet bandwagon or we're going to be history. And that changed everything all at once.
And the email system at STSC. So was this the same as at IPSA?
I think there were parallel implementations because I did my implementation and Leslie Goldsmith did an implementation of IPSA. And so I haven't had a chance to compare notes with Leslie as to what he did compared to what I did. And I don't know whether he had access to the source code that I wrote, because both of our systems were written in APL using the STSC IPSA file system as the intermediate. There were some problems that were discovered later on in what I had written because I made the assumption that there was a time ordering for what things got written to the file system. And for the sake of performance, that wasn't always true. Later on, while I was at Burroughs, I wrote another email system there, which took advantage of the fact that the Burroughs file system, when you had a hold on the file, actually implemented transactions on the file. What that meant was, if you had a hold on the file system, effectively, the changes you made to the file system were all provisional. And if you abandon the hold, the file was put back into the state it was prior to you taking the hold. And if you released your hold, successfully, everything was committed. So essentially it was the standard sort of commit transaction that you see in SQL. And we had it as part of our APL file system. And the STSC IPSA file system didn't have that. Their attitude was a hold was simply an agreement among all the parties that they would be disciplined in how they wrote to the file. That is, if you didn't have a hold on the file system, you would wait for the other person to release their hold, but there wasn't anything that prevented you from writing. It was just prevented accidentally because if you tried to get a hold, your hold would be delayed until the other person released it. And with the Burroughs file system, it was the beginning of a transaction. And you really did have absolute access to the file at that point.
Some kind of, I don't know, Ibm or something that you could ask whether the file was currently held?
For STSC, that was basically the way it worked. And it was put into a quad function at a certain point. With the Burroughs system, we had these extra symbols, things like a quad with an up arrow for it, getting a hold on a file. And a pen was quad with, I think, a right with a greater than symbol on it. So you're appending to the file. But the semantics were different. That when we actually got a hold on a file, we got exclusive access to the file and we started a transaction. And what that meant is if we wrote anything to the file, that was put in a separate area. And if we modified something, we kept the old data and the new data as well. And we kept directories on what was the old state of the file and what was the new state of the file. And if you release the hold at the end, what we did is we made that the new state of the file copied in from the directory, and we garbage collected all the old things that had been overwritten. If you broke the hold and abandoned the file hold, it simply threw away the directory of new items. So essentially, we kept the entire state of the file as it was before and as it was as we were changing it. So the visible state of the file was controlled by these two directories. If you didn't have a hold, you saw the file as it was. So if you weren't holding the file and you were just reading things and someone else was making changes, at the point where they committed all their changes, suddenly things appeared as if in a single instant.
So how was it with the systems that did not have? This was obviously a very sophisticated hold system. It sounds modern. But for those that relied on everybody behaving, how did it work then? How would you know if somebody currently had it open or not?
Well, basically what happened is it's sort of a lock where you say, agree that here's a particular piece of code that is shared by a bunch of people. So we'll have this gateway at the beginning saying you gain a hold on the file. And by agreement in the code, you didn't modify anything in that region of the file unless you had a hold.
So they would, but where was the state kept? Or it was one gigantic APL program running for everybody at once. That's how it was?
That's basically the way it was.
Ah, okay.
You're
Yeah,
saying
so
it was a semaphore that everyone had to check. It didn't actually have an effect on the file system. It was basically just a signal that
That's right.
everyone's applications agreed upon. And if you didn't have a hold on the semaphore, you didn't proceed to update the file.
But what was the nature
So
of that
essentially, it was
semaphore?
cooperation through politeness.
Sure.
There was some database of I presume, a list of the semaphores, whatever names you used, and who held that semaphore.
Sure, but I'm
Right.
questioning if it was a variable or was it another file that they had to check or a component in the file? Or...
Well, it was an aspect of the file.
So you would read a piece of the file and it would say there that somebody's holding it, and so then you would
Right.
wait.
And the
then
only place
hold.
that it came into existence where you really cared about it is if you said, I want to take a hold on the file.
Right.
And the approach was, oh, someone else has already got that hold. We'll put you in the queue and delay you until that hold is released.
Ah, so you didn't have to poll. You didn't have to wait for a little bit, then poll if it's free. You would actually, your whole program would just halt and then continue once it could continue.
That's right.
Ah,
Now, there are other systems you could make which would allow you to permissibly say, try to get, you know, if it fails. But in this case, it was sort of, okay, you try to get a hold, you just block until somebody else releases it.
All right, thank you, man. Okay, thank you.
I'm wondering, did APLSV solve some of these problems by having the Q and NQ and DQ?
They did some. The thing was, APLSV, one of the first thing that came out with APLSV was an auxiliary processor to give you access to files. And they had a mechanism where you could say, set some state on what you're allowed to do. And one of those states you could set is, I'm not allowed, if I can set it up so that I'm not allowed to write to the shared variable until somebody else has already read the shared variable. That is, it was only keeping one value state for a shared variable. Got some flags as to, has it been read? Has it been written?
There is a problem of sequencing whenever you do this kind of thing. If somebody reads a file and then somebody else reads the file and the second person updates the file before the first person updates it,
Right.
and he updates it, the second person's update is lost.
That's right. I mean, that's why you always had these things like the SVO controls or STSC files, the file hold, which gave you a way to have politeness involved. For the SVO, it basically said, okay, if I'm sharing a variable with someone else and I write if a value has been written there already and the other party has not read it, and I try to write another value, it blocks me until the other party has read that variable. So you don't want to lose things that are in a buffer.
Well,
Now,
I remember. Okay, go ahead. I'm sorry.
There were a number of pieces where there were sort of religious difference between what Burroughs did and what IBM did. And we talked with them fairly extensively about it because at that point, the IBM development on APLSV and so on was in the Philadelphia Science Center. And Burroughs was located in Paoli, Pennsylvania, which is a suburb of Philadelphia. So we'd meet with them fairly often. And they had this kind of religious notion that a shared variable existed in one place and it was shared by both workspaces. And in reality, that wasn't the way it worked at all. The shared variable was a separate buffer where data got put into it and copied out from it into your workspace. And it led to some very odd behaviors. There could be times where you were sharing a variable with another process or another APL session, and you try to disconnect your session, which would normally say to continue workspace. And when it tried to do that, you get a workspace full because it was trying at the last minute to copy in the state of the shared variable. And in the Burroughs implementation, we took the approach that a shared variable is a communications channel, that you don't get data from it unless you ask for it. So it doesn't, as a side effect of anything else you do, slam data into your workspace. So that was a major difference of opinion as to how things should work. They treated it as a variable that actually is in two places at once. And we said, no, it's a communications channel. So it was one of those things where it led to small differences at various edges in the way you operated with it. But it made a big difference in how you implemented it. When I was at Data Resources, we did a lot of things with shared variables. We had a number of auxiliary processors that allowed you to write code in ALGOL for access to a database and use it from within APL. A friend and I had come up with a protocol for constructing code written in ALGOL and just interacting with it from APL. A lot of the things that were good about APL were these connections that we made to the outside world so that APL wasn't just a complete walled garden. And it made an enormous amount of difference, because so long as it was a walled garden, that meant that you really didn't interact with the rest of the world. And in fact, many people used APL where the only way that you got information in or out was typing. And it made a big difference as soon as you had the ability to access the file system that we were operating on, or to read magnetic tapes. In fact, when we were doing the APL machine, that was a system where we didn't have anything like the APL SDSC file system. What we had was persistent APL. It was an APL with a virtual machine, which had virtual storage, and you just had a workspace. And it could have a very complicated state.
And plugged it back in again, you would still keep your state, right?
That's right. It was sort of an extreme version of you throw a bomb in the computer and it obviously shuts down, and you bring it back up and maybe you've lost some information, but it comes back to a coherent state. That was part of the design characteristics of the APL machine. Now, in fact, we did have I/O, but say the I/O typically was to read or write a magnetic tape.
Does anybody remember what became UNIVAC? The original magnetic tape, steel tapes that it took a man to lift because they wouldn't hire a woman. They were so heavy that they figured women couldn't lift the tape to the drive.
Oh.
And they had one advantage. They had one advantage.
UNIVAC exhibit at the Computer History Museum.
They had one advantage. You didn't have to thread the tape. It came in a cartridge.
Well, yeah.
I actually saw one of those step monitors.
Well, there's a classic sort of image that you see all over the internet of a 5 megabyte hard drive being loaded with a forklift into an aircraft.
Yeah, I saw that recently. It reminded me of the first drive I ever saw. It was at a computer show, and IBM was displaying their wonderful 350 RAMAC.
Ah.
It was. I suggested to my boss that we might be able to use it, and he says, doesn't have enough capacity for us.
Well, I remember when I first came to Data Resources, they were an econometric time sharing system, which had models of the entire United States economy. And it was started by a fellow named Otto Eckstein, which was one of the economic advisors to, I think, Lyndon Johnson. And they were very proud of their computer system. They showed us the computer room with row upon hard drive. And they said, it's a gigabyte of storage. And these days you can have a gigabyte or even a terabyte of storage in your pocket.
I often comment to people around here, my phone is much faster, a much greater capacity than my PC.
Yep. Well, when I was working most recently for Microsoft, I was working on their archival storage division, where the basic idea is on the cloud storage, they would allow you to designate a collection of your storage that you wanted to have at lower price, but it also meant you didn't get immediate access to it. And what's going on? We're writing into magnetic tape. Essentially, the tape cartridge were, say, 15 terabytes of data.
Takes a long time to search it sequentially.
Well, yeah. Actually, depends, because these tape drives were reading and writing at 360 megabytes per second. So yeah, you're right. With terabytes of data, it takes a while to find your data, but boy, does it come at you fast. The biggest problem we had in that system was getting the operators to understand that humidity controls mattered a lot. And we were doing redundant writes. That is, when we had a collection of archived data, it got written to 2 different tapes. And if you really wanted to be fancy about it, it got written to 2 different tapes and 2 different data centers. Because you wanted to address the problem of what happens if you have a major earthquake in one of your data centers.
We still do this today, right?
Early
It
version.
varies a lot.
When I worked for relocate the data center from one of the data centers from San Francisco to someplace in the Midwest, and they ruled out Salt Lake City because it was on a fault line.
Yeah. I mean, people really took seriously the sort of things that happened. For instance, suppose there was a meteor strike that wiped out Seattle. How do you recover from that?
With difficulty.
Well, yeah, I mean, obviously, first thing is you have to find new equipment to work with, because most of what's there is probably melted down now.
At Dialog, we make 3 copies for our backups. One we keep at our office in Bramley in England, and one we send to a secure data center next to a Navy base down on the south coast, and one we send to Denmark.
Mhm.
I guess if all of Europe gets into a mutually assured destruction war, then it all goes, but nobody will need us anyway after that, so who cares?
Adam,
Well,
NSA has a 4th copy, don't worry.
Yeah.
well, one of the funny things that happened over the years, one of the fellows that was in the classes I taught in Hampton later on decided to join the CIA. And he was in some of the meetings we had in the APL standardization. Standard joke is we'd ask Bob, we've forgotten what happened in the last meeting. Do you have a record of it? And he
Talking
actually
about
did quite
forgetting, I was in graduate school and I was taking a course with one of the great statistics mentors of the world. And I finally figured out he taught in random order. I turned to one of my compatriots and said, was I here last week? And he said, I was thinking the same thing. You just couldn't follow him.
There are a number of lecturers who had idiosyncrasies that way. There was, I think it was an astronomy professor who had the habit of writing on the blackboard, and he was a big guy. So basically while he was writing, you couldn't see what he wrote. And as he turned around, he erased what he wrote. So it was difficult to follow. And I remember Ken Iverson had the characteristic that he was ambidextrous, that he would start writing with his left hand and continue with his right hand with no break in between. So over the years, you meet quite a few interesting people with amazing talents.
Yeah, that's for sure.
I remember one of the fellows who used to be the editor for Byte magazine had the characteristic that he could hold 2 or 3 conversations on completely separate topics while typing an article and not miss a beat. More recently, I saw this when my youngest daughter was in the era of Windows 95, was on the computer holding conversations with several of her friends simultaneously while writing fan fiction for a particular program and keeping all the conversations straight, because she had to be careful that she didn't say one thing to somebody and say something different to somebody else. And she was able to do this all at once. And I was wondering, how do they do that? And I figured this is either something that the younger generation has more skill at than I do, or they just developed an ability to do this. It's sometimes very hard to keep track of things, but they had no problems.
My father, I guess it's just some people can do that. My father taught engineering students. He would write formulas with one hand while he was simultaneously drawing graphs with the other hand.
Well, there's the notion that there are actually two brains inside you, the left hemisphere and the right hemisphere, which cooperate sort of loosely. And there seems to be an opinion that they have simultaneous access to the world, but they have different opinions about what's important. The left hemisphere supposedly is very detail oriented and is tightly focused on very narrow aspect, whereas the right hemisphere, as far as people can determine, seems to keep track of the overall state of your body and what's going on. It's the right hemisphere who will notice there's a tiger over there that we should worry about.
So which hand did your father draw the graph with?
He was a righty. He wrote with his right hand and drew the graph with the left hand.
His left hand. Okay, because I remember an incident in a bar one time when I had a little bit of beer to drink, and I was able to draw a very nice picture, and I can't draw anything with my left hand.
Yep.
So I suppose there's a lot of truth to that, right brain, left brain sort of thing. And,
there used to be a thing that if you want to be good at APL, you have to be a left-handed Canadian.
Yes, and you have to master the Canadian alphabet too.
So is Arthur Whitney left-handed?
I don't think so. 1980s when I met him. Wasn't then.
But Roger Huey is, I think.
No.
No?
No.
I don't know, but a lot of people had connections that way. I'm told that when I started writing, I was writing with my left hand, and Mom asked me, "Can you do that with your right hand?" And so I did. And
In my case, I wasn't asked. I was forced. I had a nun in 1964 do that to me, hemisphere switching. So I turned out to be adextrous, not ambidextrous.
Well, I used to say I was ambidextrous in the sense that I could write equally badly with either hand.
Okay, that's a good way to look at it.
Half full, half empty kind of thing.
Well, I had a friend in college who did a lot of work with calligraphy, and he could do the work on calligraphy with both hands simultaneously.
Well, maybe APL has a benefit there in being more picture symbol oriented. You can maybe pull in some of the processing power of the brain that normally wouldn't be used in a very text-based, word-based programming setup.
Yeah, and there's a lot of things that goes on in APL when you're thinking about things in terms of the patterns of what you're doing. Because sometimes you think in computer work in terms purely sequential, you do X, then Y, then Z, and so on, and make decisions. But a lot of times when you're dealing with APL, you just think about the entire pattern. It's more like looking at it globally and going from global to the very specific. And that's one of the nice things about APL, that you can have a pattern that goes throughout.
Often when I think about problems, I see the solution in terms of APL code, which wouldn't work, but the concepts of that.
Well, that, and while I was working for Microsoft and various other places, quite often if I had a problem to solve, I'd write it out in APL and then translate it into C or whatever language you happen to be using, say assembly maybe. It was a way of thinking about the problem. So as Iverson often said, APL is the tool of thought.
I
Well, that works for
really
me.
agree
Prototype.
with that. when I was in 8th grade, going back to left hand, right hand, I broke my arm and my right hand was in a cast. And I had a teacher who insisted that I should write the answers to a quiz with my left hand. And I managed to do it, but I lost the ability to write with my left hand when my right hand recovered.
Okay, I think our hour is up. Thank you so much for contributing. If you want to be the guest of honor in a future session, you can let me know. By any way of contacting me, you can write to adam@dialogue.com. Easy one. And it's been really enjoyable. I hope we'll continue this in 4 weeks. Thank you so much, Ron, for coming in and volunteering your life in front of everybody.
Oh, it's my pleasure. It's sort of amazing the number of interesting people I've met in the APL community.
Lots of interesting characters.
Oh, yeah, indeed.
So, thank you so much, everybody, and have a good day or night.
Okay,
It
take
was
care.
really nice to meet everybody.
Okay, bye-bye. Good night.
Take care.
Good night.